Good morning, class. In our today's class, we'll see about the characteristics of catalyst, what is a promoter, what is catalytic poison, and theory of catalysis. Now, characteristics of a catalyst. As we know, a catalyst is a substance which increases or decreases the rate of the chemical reaction but remains unchanged at the end of the reaction. So the first characteristic is it remains unchanged in mass and composition at the end of the reaction. Number two, a small quantity is required. So catalyst is always used in a very small quantity. Very small. Next, it is specific in action. Say for example, for a specific reaction, a specific catalyst is used. We can't use all the catalyst for same reactions. Number four, does not initiate the reaction and alter the position of equilibrium. So catalyst does not initiate the reaction, it does not start the reaction, and it also does not change the position of equilibrium. It only increases the rate of the reaction. Next, what is catalytic promoter? Catalytic promoter is defined as a substance which is not a catalyst for a reaction but increases the activity of the catalyst used in a reaction. So catalytic promoter is a substance which is not a catalyst but increases the activity of the catalyst. Say for example, in Haber's process, if you have seen, we have manufactured ammonia by the use of nitrogen and hydrogen in the ratio of 1:3, and we have used iron as a catalyst, finally divided iron as catalyst. Over there we'll use molybdenum, MO, or aluminum oxide, which acts as a promoter. The use of this molybdenum or aluminum oxide will increase the activity of that finally divided iron. So a promoter increases the peaks and cracks on the surface of the catalyst, therefore increases the number of free valences, thus the concentration of reactant which are bound by this free valences increases at the surface of the catalyst. Next, catalytic poison. A foreign substance which renders a catalyst ineffective is known as catalytic poison. Poisons are generally effective in heterogeneous catalysis. So catalytic poison means which hinder or which stops the activity of the catalyst. Say for example, sulfur or quinoline in Rosenmund reduction reaction. Okay, so in Rosenmund reduction reaction, the use of sulfur or quinoline decreases the rate of the reaction or control it. Similarly, arsenic oxide is a poison in contact process. Iron, the catalyst in Haber's process, is poisoned by H2S. Iron catalyst used in the oxidation of hydrogen is poisoned by carbon monoxide. The poisoning of catalyst is probably due to preferential adsorption of poison on surface of catalyst. This reduces the surface of the catalyst and therefore the free valences. In some cases, catalyst chemically reacts with the poison. Next, theory of catalysis. First one is intermediate compound formation theory, and the second one we have got adsorption theory. Now let us see what this theory tells us. So in case of intermediate compound formation theory, this theory is applicable for explaining the phenomenon of homogeneous catalysis. Homogeneous catalysis we have done in our previous classes, where the reactant and the catalyst are in the same phase. According to this theory, one of the reactants combine with the catalyst to form the intermediate, which again combines with the another reactant to form the product and regenerates the catalyst. So in intermediate compound formation, what will happen? The catalyst will react with the reactants, with one of the reactants, and it will form an intermediate. This is an intermediate. Now, which again combines, the intermediate combines with another reactant to form the product and regenerate the catalyst. So this is intermediate compound formation theory. Next is adsorption theory. Adsorption theory. This theory explains heterogeneous catalysis. That means the reactant and the catalyst phase are different. According to this theory, okay, the example is given over there. This is ethylene, or we can call ethene, carbon-carbon having a double bond. When you add hydrogen in presence of nickel, that double bond will break and one hydrogen will get added, so it becomes C2H6. Now, According to this theory, the surface of the catalyst has a large number of unsatisfied free valences or active centers which can undergo loose chemical combination with the reactant molecules. The number of active centers can be increased if the catalyst is taken in powdered form or in broken form, thereby increasing the surface area. It can also increase if the catalyst has large number of peaks, edges or cracks. So first, the catalyst have got the free valences. And this free valences, or we call active centers, and this can be increased if the catalyst is taken in powdered form, because it will have the large surface area. The second is the reactant molecules adsorb at the surface of the catalyst with the help of the formation of weak van der Waals forces of attraction. So what will happen on this catalyst nickel? The reactant molecules, say for example we can take ethene. Okay, so they will adsorb on the surface of it. This hydrogen gas or ethene gas will adsorb on the surface of this catalyst by a very weak van der Waals forces of attraction. As adsorption is an exothermic phenomenon, the liberation of heat breaks the reactant molecules to convert them into atoms. So what will happen, since adsorption is the exothermic process, that means heat is get liberated, the reactant molecules break down into atoms. Therefore the energy of the molecules get lowered and the activation energy is also decreased, and the reactant atom combines with the adjacent molecule of another reactant to form activated complex, which readily combines with the another form to form the product. So what happens, the reactant molecules, since adsorption is exothermic process, it will break down into atoms, and these atoms will combine with another reactant molecules to form activated complex, which will result in the formation of the product. When the product is formed, the product molecules leave the surface of the catalyst, making them ready for further reaction. So when the product is formed, it will leave the surface of the catalyst, making it for further reaction. Now today's assignment 10. Question number 1, write the characteristics of a catalyst. Question number 2, define catalytic promoter, give examples. Question number 3, define catalytic poison or give examples. Question number 4, explain the following theory of catalysis: intermediate compound formation theory and adsorption theory. So complete this assignment and send it in my